Jai Shri Gurudev. Good morning to everyone, students. The next concept is preparation of phenols. Preparation of phenols. There are so many methods to prepare phenols. The first method is from cumene, very important one, from cumene, or we also called as a cumene process. Cumene process. From cumene we can prepare phenol. The cumene is heated at 100 to 130 degrees Celsius. On oxidizing, you get cumene hydroperoxide, which is then heating at 100 degrees Celsius in presence of concentrated sulphuric acid. You get phenol and acetone as a byproduct. So this whole process is called as a preparation of phenol from cumene. So see the chemical reaction. This is cumene imported. This is the benzene. Here one CH group, bond CH3, bond CH3. So this is called as a cumene. The common name is cumene and the IUPAC name is C1, 2, 3. This is the longest parent chain. So IUPAC name is 2-phenyl propane. 2-phenyl propane. So this is the IUPAC name, but I am writing in bracket here. This is common name cumene. Remember, this is IUPAC name 2-phenyl propane or isopropyl benzene. Isopropyl benzene is the common name or IUPAC name. IUPAC name is 2-phenyl propane. Now this cumene is an oxidizing, that is treating with oxygen. Oxidizing at 100 to 130 degrees Celsius, not Kelvin, Celsius. At this temperature, which is an oxidizing, you get a compound like, that is right, benzene. So this O is added between carbon and hydrogen. Carbon, bond CH3, bond CH3. See, here there is carbon, right, and hydrogen. Between these two, the oxygen is added like O, bond H. This is oxygen is added. So its name is called cumene hydroperoxide. Cumene hydroperoxide. So whenever you see oxygen bond oxygen, that we call peroxide. Cumene hydroperoxide, this is called as cumene hydro and peroxide. Now this cumene hydroperoxide is heating at 100 degrees Celsius in presence of concentrated sulphuric acid, H2SO4. In presence of concentrated sulphuric acid, which is heated at 100 degrees Celsius, usually write this concentrated sulphuric acid above the RMR because which is adding first concentrated sulphuric acid followed by heating at 100 degrees Celsius. So at this temperature, this cumene hydrogen peroxide is converted into phenol. See, this OH group is get attached to the here and this O bond is removed here. That is the mechanism. See here, like that the reaction will takes place. You get benzene. This OH is directly attached to the benzene, that is phenol, plus the remaining is CH3, CO and CH3, that is CH3 bond CO, CH3. Okay, you know this is called what? Acetone or 2-propanol, and this is, you know well, phenol. So this is the one of the methods to prepare phenol from cumene, very important for 2 moles. Each reaction you get 1 mole. This is the reaction condition and this is the second step reaction condition. Okay, this is the one of the method to prepare phenol from cumene, very important. Then the second method is from Diazonium salts. The second method is from Diazonium salts. Here, to prepare phenol from diazonium salt, aniline is heated with sodium nitrate with HCl at 0 to 5 degrees Celsius to get benzene diazonium salt, that is BDC, benzene diazonium chloride, if we are taking HCl, then which is warm with water. Warm is nothing but just we are heating to boil or just to warm the solution with water to get phenol along with the liberation of nitrogen gas and HCl gas. Okay, this is the one of the best method to prepare phenol from laboratories or in laboratories. Laboratory alli ನಾವು prepare ಮಾಡಬೇಕಾದ್ರೆ ಇದೊಂದು ಬೆಸ್ಟ್ ಮೆಥಡ್ ಅಂತ ಹೇಳ್ತೀವಿ from diazonium salts. Okay, so here aniline, see the chemical reaction, benzene ring with the N2 group, that is NH2 group, is called as what? Aniline. This is nitro compound aniline. This aniline is treated with sodium nitrate, NaNO2, sodium nitrate in HCl at 0 to 5 degrees Celsius. This is the reaction condition. At this temperature, this phenol, this aniline is converted into benzene diazonium salt. This is benzene bond nitrogen N2Cl, right, like that. This is called benzene diazonium salt. Simply write BDC, benzene diazonium chloride. Now this benzene diazonium chloride is warm with water. So water ಜೊತೆ ಏನು ಮಾಡಬೇಕು? ಹೀಟ್ ಮಾಡಬೇಕು. On heating you get phenol. See, benzene, here there is N2, right, that becomes N2 gas, nitrogen gas, like carbon dioxide. Then the Cl and 1H of water becomes water, HCl. And in H2O, 1H minus plus H plus is there, right? This H plus and Cl becomes HCl, and this OH is get attached to the here. What you get? Phenol. Okay, now this nitrogen gas is liberated and HCl is also eliminated like HCl gas. You get pure phenol. This is the best method to prepare phenol in laboratories. This is the second method. Then take a third method. The third method is from benzene via sulfonation. This is the third method to prepare phenol. So in this process, the benzene is unsulfonated by treating with sulfuric acid mixture or with volume. You get the benzene sulfonic acid. This benzene sulfonic acid is treating with sodium hydroxide. Treating with sodium hydroxide, which is on acidifying, means neutralizing to get phenol. This whole process is known as preparation of phenol from benzene sulfonic acids or benzene via sulfonation. Okay, now observe this process. This benzene is treating with oleum. Oleum means sulfonation. This sulfonation is one of the process. This volume molecular formula is H2S2O7. This is the volume compound used to sulfonation of benzene. Also can use sulfuric acid to sulfonate this benzene with nitric acid mixture. Now this benzene becomes sulfonated. You get benzene sulfonic acid. This benzene and SO3H. This is called benzene sulfonic acid. Benzene sulfonic acid. This benzene sulfonic acid is treating with molten sodium hydroxide, followed by acidifying, that is treating with acid, that is HCl. See here, when we are treating with molten sodium hydroxide, this benzene sulfonic acid becomes sodium benzoate, like that is ONA. ಈ ತರ ಬರುತ್ತೆ. ನಾವು ಮಾಲ್ಟನ್ ಸೋಡಿಯಂ ಹೈಡ್ರಾಕ್ಸೈಡ್ ಜೊತೆ ಬೆಂಜಿನ್ ಸಲ್ಫೋನಿಕ್ ಆಸಿಡ್ ಜೊತೆ ಟ್ರೀಟ್ ಮಾಡಿದಾಗ ಸೋಡಿಯಂ ಬೆಂಜೋಯೇಟ್ ಬರುತ್ತೆ. ದಿಸ್ ಸೋಡಿಯಂ ಬೆಂಜೋಯೇಟ್ ಆನ್ ಹೈಡ್ರಲೈಸ್ಡ್ ಅಸಿಡಿಫೈಡ್ ವಿತ್ ಆಸಿಡ್. ಆಸಿಡ್ ಜೊತೆ ಟ್ರೀಟ್ ಮಾಡಿದಾಗ ಈ Na ಪ್ಲೇಸ್ ಅಲ್ಲಿ H ಬಂದು ಕೂತ್ಕೊಳ್ಳುತ್ತೆ. ಯು ಗೆಟ್ ಫಿನಾಲ್. ಸೊ ಫೈನಲಿ ಯು ಗೆಟ್ ಎ ಕಾಂಪೌಂಡ್ ಲೈಕ್ ಫಿನಾಲ್. ಬೋತ್ ದಿ ಸ್ಟೆಪ್ಸ್ ವಿ ಆರ್ ರೈಟಿಂಗ್ ಇನ್ ಸಿಂಗಲ್ ಸ್ಟೆಪ್ that we called phenol. This is the phenol. This is the one of the method to prepare phenol from sulphonic compounds. Then the fourth one is, the next method is from phenols. From benzene. Not benzene. From fourth one, from halogens. From halogens, or we also call it from chlorobenzene. Particularly we are taking chlorobenzene. This is an example for halogens. Here the chlorobenzene is treated with sodium hydroxide at 623 Kelvin and 300 degree atmospheric pressure. That is the reaction condition. At that temperature you get benzene or sodium benzoate. That sodium benzoate is on acidifying with dilute HCl, get phenol. Okay, so see the chemical reaction. Take chlorobenzene. This chlorobenzene is treated with sodium hydroxide, means fused with sodium hydroxide, means we are keeping these two in a tube by fusing at the temperature of 623 Kelvin and 300 degree atmospheric pressure. ATP, atmospheric pressure. Atmospheric temperature and pressure, 300 degree atmospheric temperature pressure, you get sodium benzoate. Bond, this H and Cl becomes HCl is eliminated and remaining is NaO. That is ONa. You get sodium benzoate. What its name? Sodium. This is sodium and this is benzoate, which is treating or obtained by chlorobenzene. Okay. Now this sodium benzoate is neutralizing, acidifying with HCl. Now HCl ಜೊತೆ acidify ಮಾಡಬೇಕು. ಯಾವಾಗ ನೆನಪಿಟ್ಕೊಳ್ಳಿ, ನಿಮಗೆ ಸೋಡಿಯಂ ಬೆಂಜೋಯೇಟ್ ಬಂತು ಅಂದ್ರೆ HCl ಜೊತೆ ಟ್ರೀಟ್ ಮಾಡಬೇಕು. ಆವಾಗಲೇ ಬರ್ತಿದ್ದೆ ಈ ಲಾಸ್ಟ್ ಸ್ಟೆಪ್ ಅಲ್ಲಿ 2 ಸ್ಟೆಪ್ಸ್ ಅನ್ನು ಒಂದೇ ಸ್ಟೆಪ್ ಅಲ್ಲಿ ಬರ್ತಿದ್ದೀವಿ ಅಂತ ಹೇಳಿದಾಗ ಸೋಡಿಯಂ ಬೆಂಜೋಯೇಟ್. That benzoate is acidified with HCl, you get benzene. So you get phenol, that is OH. In place of NaH is added and NaCl becomes NaCl salt, that will be eliminated. Here the presence of water, it will be dissolved and go out, means eluded from the reaction. You get phenol. This is the fourth method to prepare phenol. There are 4 methods. First one is from cumene, and the second one is from benzene. Then third one is sulfonation via benzene, and the fourth one is from halogens. These are the 4 methods given in your syllabus to prepare phenols. Definitely anyone will be asked among these 4. Here from cumene is the most important one. Okay. Then the next concept is properties of phenol. Properties of phenol. You know there are 2 types of properties basically. The first one is physical property and the second concept is chemical properties. Now take the first one is physical properties. So here under the physical properties, the first one is boiling point. That is boiling point. The boiling point of phenols is always higher than the corresponding hydrocarbons or ethers or acidic chlorides or esters. Means the compound of phenols or the phenol which is obtained from respective their compounds. ಅಂದರೆ ಯಾವ ಕಾಂಪೌಂಡ್ಸ್ ಇಂದ ಫಿನಾಲ್ ಉತ್ಪತ್ತಿ ಆಗುತ್ತೋ ಅಥವಾ ಫಿನಾಲ್ ಉತ್ಪತ್ತಿ ಆಗೋದಕ್ಕೆ ಯಾವ ಕಾಂಪೌಂಡ್ಸ್ ಹೆಲ್ಪ್ ಆಗುತ್ತೋ ಆ ಕಾಂಪೌಂಡ್ಸ್ಗೆ ಕಂಪೇರ್ ಮಾಡಿಕೊಂಡಾಗ ಫಿನಾಲ್ಸ್ನ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಅನ್ನೋದು ಜಾಸ್ತಿ ಇರುತ್ತೆ, ಬಿಕಾಸ್ ಫಾರ್ಮೇಷನ್ ಆಫ್ ಹೈಡ್ರೋಜನ್ ಬಾಂಡಿಂಗ್. So remember the boiling point, phenol boiling point is always higher than corresponding corresponding hydrocarbons are compounds. This is due to formation of hydrogen bonding. Hydrogen bonding. This is the first one. Then second one is solubility. Solubility. Here the solubility of phenol in water is always higher because the formation of hydrogen bonding with water. So see here, phenol solubility is high in water because see, this is the structure of phenol, bond O, bond hydrogen. So take the hydrogen molecule, that is O, bond H, bond H. This is hydrogen molecule, right? This is water, sorry, not hydrogen, this is water molecule. Now, from hydrogen to the oxygen, the bond is formed like that. That is called hydrogen bonding. This hydrogen bonding is formed between water molecule and phenol. Hence, the solubility of phenol is high. Means phenol is soluble in water. Then the third one is the acidity. Acidity means acidic character. The phenols are slight acidic in nature, due to the formation of phenoxide ion. This phenoxide ion is stabilized by resonance. See, in acidic character, if you take phenol, bond OH, this is phenol. Now this phenol is unionizing or dissociating to get O minus plus H plus ion. Okay, here the H plus is eliminated. After removing this H plus ion, you get the phenoxide ion. This is the benzene, right? This phenoxide ion negative charge is stabilizes or resonates with these pi electron cloud present in the benzene. If phenoxide ion is pi electrons resonate agutte, therefore this phenoxide ion is stabilizes. Hence, it is slight acidic in nature. Then slight acidic nature of it. This is the acidic character, not fully acidic. Then third one, but it is acidic than water. Water means the phenol another acidic hydrogen. Again, it is stabilizer. Then the next one is the acidic character which increases by presence of electron withdrawing group or electron donating group. D is there. The electron donating group decreases the acidic character. Remember, the presence of electron donating group decreases the acidic character. That is the order is phenol. The order is very important for 2 moles. Electron donating group decreases the acidic character. The order is phenol is more acidic than phenol with methyl group, that is 3-methyl phenol, which is more acidic than the methyl group at para position. This is the para-methyl phenol, and which is more acidic than phenol with ortho, O and CH3. So this is forming the intermolecular hydrogen bonding. Intermolecular hydrogen bonding form this methyl group is electron donating group, so that it donate electron towards the benzene ring. Hence, the electron density and oxygen atom is increases, so that the bond of oxygen and hydrogen is decreases. Means the strength is increases. It will be not broken easily. ಅದು ಈಸಿಯಾಗಿ ಬ್ರೋಕ್ ಆಗೋ ಸಾಧ್ಯತೆ ಇರೋದಿಲ್ಲ. Okay, therefore this is the order of acidity, that is decreasing order. Here phenol is more acidic, then meta-methyl phenol, then para-methyl phenol and ortho-methyl phenol. Similarly, the last one is electron withdrawing groups, donating group. This is withdrawing group. This is releasing group also. Electron withdrawing group increases. See here W. W means increases, D means decreases. If you remember D, then automatically you can write W. That is, electron withdrawing group increases the acidic character. Electron donating group decreases the acidic character. Then the order of these electron increasing character is phenol. That is benzene with OH. This phenol is more acidic than orthonitrophenol, which is more acidic than metanitrophenol, then which is more acidic than farnitrophenol. So this is the strength of phenol. It is decreasing order like that. It is more acidic, then second, third and fourth. This is the acidic character of phenol. So here the physical properties is completed. Then next one is chemical properties. We will study it in next class.